One of the worst approaches you can possibly take when it comes to learning thermostat wiring or wiring at control boards is to use this color code mantra that seems to be so popular with YouTube videos and so many links on the internet. This color code thing isn't exactly wrong, but when it comes to realities in the field, more than half the time it's not right. I'm going to explain why it's wrong and what approach you can actually take, which is far more dependable and reliable to learn low voltage control wiring in heating and air conditioning systems. So let's start with this. The HVAC color code is not actually a code. There's no inspectors out there holding anybody's feet to the fire, making sure there's a white wire on W or a yellow wire on Y. What this basically is it's a suggestive kind of feature of the industry where if you have a certain number of conductors and a certain number of colors to work with, and you have the option of using those colors according to this code, you should do that. That kind of helps keep everybody on the same page. But the reality is that you have situations where a unit might have been installed 30 years ago. Let's say it's a straight cooling system. It only needs 3 wires to run. And so the contractor only actually ran 3-wire thermostat wire, which means all you have is red, white, and green. You don't have a yellow, you don't have a blue. And in situations like that, it would be perfectly acceptable to use that white wire on the Y terminal, have a fully functional system, passes inspection, everybody's happy, and life goes on. Now, these situations are extremely common with all different types of systems, different types of thermostats. So the best approach you could possibly take in learning how to do all this wiring is not to go by color code. It is to actually understand what each terminal's function actually is. Each one of the terminals on control boards or thermostats activates a very specific component in the system. Now, all heating and air conditioning systems have a transformer somewhere in that system. So whether we're talking about boilers, furnaces, air conditioners, there is a transformer that takes high voltage coming into the main unit and steps it down to 24 volts. And that 24 volts is always fed to these R terminals. So if we're talking about an R terminal on a control board, R terminal on the thermostat, even R terminals on defrost control boards and heat pump systems, that R terminal is receiving 24 volts from a transformer, and this is the voltage that is the beginning of all our low voltage control circuits in our system, regardless of what kind of system we're talking about here. Now, the good news when it comes to color code is that all thermostat wires, regardless of how many conductors are in them, whether there's only 2 wires or 5 or 8 wires, they all have red wires that come with them. So this is the one aspect where color code is usually spot on. You will usually find a red wire on an R terminal. Now, it's not the same thing as saying that all red wires go to R terminals. They do not. There are situations where you'll have red wires on other terminals, but you can pretty much bank on the fact that R terminals will actually have a red wire on them. Now, these R terminals, they're always constant power. They're not turned on and off. There will always be 24 volts there. If you do not have 24 volts on an R terminal, there is some interruption in the power supply for some reason. We're talking about trip breakers, blown 3 or 5 amp fuses on control boards. Sometimes you might have a wet switch that interrupts power to a thermostat, for example, if we have condensation that's backing up, not draining properly. But these are constant power supplies, and if you have any other wires coming off of an R terminal, regardless of what color it is, that is a constant 24 volt power supply going somewhere. Now, the ultimate first destination for these 24 volts on all these R terminals is the R terminal on our thermostat. That is the main control component in our system. Once again, we're talking about boilers, furnaces, air conditioners, doesn't matter. The 24 volts needs to go to the thermostat so that the thermostat can ultimately make decisions on what components to turn on and off and when. Now, if you have a thermostat with 2 red wires, 2 R terminals, what you have there are 24 volt power sources coming from 2 different units. So you might have a separate heating system and a separate cooling system. Each one is sending 24 volts independently to the thermostat. So we're talking about 2 power sources here and not just 1. Now, with thermostats being the main control component in our circuits, the thermostat is going to take that 24 volts on an R terminal and send it to an appropriate destination based on different modes. So the W terminal on thermostats is typically for a heating mode. So this can go to different places depending on what kind of system you have. If you have a boiler, the chances are that W terminal is going to go to a zone valve. If you don't have zone valves and you have circulator pumps, that 24 volts off of that R terminal going to the W terminal on the thermostat is going to go to a relay that activates high voltage to a circulator pump, starts circulator pump. If we have a furnace, that W signal is going to be sent back to the control board in the furnace itself, and that 24 volt signal received on the W terminal and control board is going to start the whole sequence of operations to light the furnace up. If you have an electric furnace, that W terminal will send 24 volts likely to a relay that activates the high voltage to your heating coils, and your heating elements will start heating up. Heat pumps are a little bit different. Usually the W terminal is not often used for the main source of heat. A lot of times if a W terminal is used, it's as an auxiliary source of heat. Sometimes you'll have thermostats that actually have auxiliary or W2, where the second stage of heat above the heat pump itself. So let's say your heat pump system can't actually meet the temperature setting on your thermostat and it's struggling to get to that temperature. Either W2 or an auxiliary terminal on a thermostat will activate and kick in the secondary source of heat. So a lot of times that might be a heat strip, it might be a furnace, it could be any other source of heat that activates on top of the heat pump system to kind of help give it that extra boost. A lot of times there might be thermostats where the W terminal is not used at all on a heat pump system, especially if you have a Honeywell thermostat. If you hook a white wire up to W1 on a Honeywell when you're running a heat pump system, don't be surprised if you have yourself a $700-800 electric bill that first month. For some reason, Honeywell thermostats in heat pump circuits will always activate that W terminal even in cooling mode, and so what you have is a situation where your air conditioning and your heat strips are running simultaneously, hence the high electric bill. And so when it comes to a heat pump system, usually you're going to see a white wire more on auxiliary or W2 rather than W1, but there might be some systems out there that might actually use a white wire and W, but you really have to kind of know what kind of system you have, what kind of thermostat you're working with there. Now, the other good thing about color code is that all conductors come with a white wire as well, whether we're talking about 2-wire or 8-wire. So this is the only other situation where you will often find a white wire on a W terminal, which again is not the same thing as saying all white wires go on W. W1 and W2 activates different stages of heating. So on a gas furnace, your W1 will activate the solenoid on the gas valve, open it up to a certain position, allowing a certain amount of gas, which delivers a certain number of BTUs. On a two-stage furnace, with a two-stage gas valve, when W2 is activated, that solenoid on the gas valve will open up even wider, allowing more BTUs in, which is a higher stage of heat. Now, there are dual purposes for these W1 and W2 terminals on furnaces. Sometimes these signals can also double up as an indicator for the blower speed on the furnace itself. So not only does the solenoid on your gas valve at like first stage open up to a certain point, but it can also tell the blower to run at a certain speed. And when W2 activates, the solenoid will open on a gas valve wider to its second stage and also kick up the blower at a higher speed. So sometimes W1, W2 can have dual purposes. The color wire you're going to find on W2 could pretty much be anything. There's really no standard out there. Sometimes it might be black, it could be brown, it could be whatever. But the whole purpose of that W2 is to activate a second stage of heating. So if you have gas, it's the second stage on the gas valve. If you have a electric furnace, it might be another bank of heating coils that kicks in on top of the first bank. And once again, when we go back to heat pump systems, W2 will be that second stage. Sometimes auxiliary will be used, but you're usually not going to see both W2 and auxiliary on heat pump systems. It's usually going to be one or the other. And again, that W2 auxiliary can be any color wire. It could be black, it could be brown, whatever, but that is its purpose. It's to kick in an extra stage of heat if the first stage isn't quite doing it. Now, beyond red and white wires, this is where the whole thermostat color code situation tends to really start breaking down and falling apart. Now, Y terminals are often the places where you're going to find the most deviation away from this whole color code thing. And there's a couple of reasons for this. Number one, you might have a system, let's say, that was installed 20, 30 years ago. Back then, it was a straight cooling system. They only need 3 wires to run it. And so all they did was actually run 3-wire thermostat wire, which means all you have is red, white, and green. You could still use those 3 wires to hook up a straight cool system and it'll run perfectly fine. But in that case, you're going to have a white wire on Y instead of yellow, because in 3 wires, you don't have yellow, you don't have blue. All you have is that white wire. So that's one situation where you'll see deviations away from this. Another sticking point for me anyway is that it's often taught that Y is for cooling. Now, 90% of the time that's true, but there are situations where that's not actually the case. So in the heat pump system, for example, the outdoor unit must run whether it's in heating or cooling mode. And so that Y terminal will actually activate in heating mode on a heat pump system. So I always like to tell people that Y terminal, rather than say it's for cooling, it is for the contactor on the outdoor unit. So the contactor, when it's activated, it pulls in, it supplies 230 volts to the compressor and the condenser fan motor, and that's what turns the outdoor unit on. So to think of the Y terminal as the contactor on the outdoor unit, you will always be correct. Now in 2-stage cooling systems, you'll have a Y2, and this usually will activate a second stage on the compressor on the outdoor unit. It can also activate a different blower speed on the indoor unit, just like W1 and W2. So the Y1 will activate the outdoor contactor to turn on the outdoor unit, might also set the blower at a certain stage on the indoor unit. Y2 will also activate the compressor at a second stage for a higher stage of cooling, while also activating the blower on the indoor unit at a higher speed. A Y2 can be any different color. Sometimes you'll see blue used for this purpose, sometimes you'll see a brown wire used for this purpose, but the whole purpose of Y2 is to either activate a second stage compressor or a higher speed on the blower motor. Now the interesting thing is that even if you do have a yellow wire available and you do see a yellow wire on the Y terminal of your thermostat, when you go to the other end of that wire to the control board in the air handler, you might actually see a different color wire landing on that Y terminal along with that yellow wire. But the purpose of those other wires is exactly the same. It turns on the contactor on the outdoor unit. So even though if it's coming from yellow from your thermostat, you might see a red or a white wire on that Y terminal in the air handler, and just know that serves the same purpose as the yellow wire. It's just sending 24 volts out to that contactor, and the common coming back to complete that whole circuit might not be a blue wire, it might be a white wire. So you could see red coming from Y on your indoor control board to your contactor on the outdoor unit, and the white being used as a common coming back from the contactor to the indoor unit to the common terminal on the indoor unit, which completes the whole circuit, and that goes back to the common on the transformer. So in the beginning of the video, we talked about how our terminal is the 24 volt power source fed by a transformer. That common terminal on the control board is the end of that circuit going back to the common on the transformer. So you got 24 coming out, you got the common coming back regardless of what color wire it is. So any wire on a C terminal is the end of a circuit, right? That's going back to the common on the transformer. Now I know this video is a little more complex than yellow goes on Y, but this is how you actually learn the voltage control wiring, and I have tons of videos. I mean, that's the focus of my channel here, is to get into all this stuff and to get into the weeds, to understand what terminals are doing, what those circuits are activating, what components are turning on and off based on these circuits. So if you want to get deeper into the weeds, you want to get into heat pump systems, boilers, furnaces, air handlers, it's all there on my channel. You can just go check those videos out. Now, just to finish off here, I really don't care if you like or subscribe. I'm not going to ask you to do that. But the way YouTube works, if you want this information to get out to other people, if you want other people to learn this stuff, and you think it's worth sharing, you do have to interact with the video. That tips YouTube off and they show more people. But otherwise, just thank you for watching. That's good enough for me. Hope that helped.